Okay, Assalamualaikum. So today we proceed with the other topic, which is the inferences about the regression parameter. It is the continuance from the previous lesson that you have learned before this, which is we are using the matrix approach to find the regression equation ataupun regression function. Okay, and then from the previous lesson, you have learned how to obtain the value of each of the parameter, which is you estimate each of the beta, and also you can find the um, ANOVA table and test for the significance of the model and find the R square and also the coefficient of multiple correlation. So today we proceed with the inferences about the regression parameter, which is in this topic. You will learn how to, we can check whether our variable, kan, kalau multiple regression, we have several independent variables. So now we can check whether our independent variables are significant or not. Okay, we can check untuk individual independent variable tu significant or not, ataupun whether that independent variable is give the contribution in explaining the why. Okay, we can use the inference of the regression parameter. And also, we can find the value of confidence interval for each of the parameter. Okay, so each of these, to find each of these, we need the value of the variance dan juga standard deviation of the parameter. Okay, so kalau you tengok in this formula in your textbook ni, page 2 to 7. Okay, this is the variance-covariance matrix of beta, which is the coefficient. Kalau sebelum ni, when we deal with when we deal with a simple linear regression, the variance-covariance matrix will be 2 by 2, right? Will be 2 by 2 matrix, which is the formula sama, cuma you punya matrix covariance matrix kat sini will be the value of the variance for beta naught, di sini variance untuk beta 1, dan di sini adalah dipanggil covariance between beta naught dan beta 1. Di sini pun sama dengan ini, kan? Okay, so ini kalau simple linear regression, we will have 2 by 2 variance covariance matrix. Our intention actually adalah nak dapatkan value of these two, right? Variance untuk beta naught dan juga variance untuk beta 1. So daripada sini kita boleh cari confidence interval. We can check for the significance of the model juga. Okay, kita boleh gunakan the slope. Right, so kalau in multiple linear regression, you punya variance covariance matrix will be P by P, which is the number of parameter by number of parameter. So let's say we have one y, we have x1 dan juga x2, we have two independent variables. So we deal with the multiple linear regression. So kita punya matrix covariance matrix will be 3 by 3. Number of parameternya will be 3, which is our regression function will be y hat plus beta equal to beta naught plus beta 1 x1 plus plus beta 1 x1 plus beta 2 x2. So kita punya parameter will be 3. So because of that, here will be 3 by 3. Our intention actually untuk ni contoh our intention untuk dapatkan variance untuk beta naught, variance untuk beta 1 dan variance untuk beta 2 contohnya kat sini. Okay, if we have let's say 4 x, so you punya variance covariance matrix will be 5 by 5. Okay, each of this kat sini, dekat sini sama ni, ini adalah covariance between beta naught and beta 1. Di sini pun sama. Let's say dekat sini, ini adalah covariance between beta naught dan beta 2. Dan sehinggalah, di sini will be the covariance between beta naught dan beta P minus 1. Okay, kalau you ada 5x, kat sini will be B5 lah. Okay, so how to get this variance-covariance matrix? We can estimate using this formula, which is sigma square multiply x transpose x inverse. Okay, you know how to find this matrix, kan? X transpose x, then inverse kan that matrix. Lepas tu, you kena multiply dengan variance of the model. Okay, variance of the model, which is MSE. We estimate the variance of the model dengan MSE. So because of that, okay, we use this formula. Kita estimate sigma square B dengan S square B. This is the formula. MSE multiply X transpose X inverse. Okay, so macam kita bagi tahu tadi lah, di sini will be the estimated variance untuk beta naught, estimated variance untuk beta 1 dan juga sehinggalah estimated variance untuk B P minus 1. Okay, once you have the MSE dan juga X transpose X matrix dan inverse that value, then you akan dapat matrix of variance covariance, matrix of B. Okay. Okay, and then we will use all this value, okay, variance of the parameter ni sebenarnya. Kita boleh check for the, kita boleh determine the confidence interval, interval untuk beta dan juga test untuk beta. Okay, so let's say lah kita ada tadi x1 dengan x2, kita punya beta will be beta naught, beta 1 and beta 2 because of we have 2x tadi contoh lah, I buat contoh. Okay, so this formula you pernah jumpa sebelum ni kan. Ini adalah formula untuk dapatkan confidence interval for the each parameter. So di sini BK, let's say nak cari confidence interval untuk beta 1, so here will be B1 plus minus T1 minus alpha over 2 N minus P. Di sini will be N minus P. Kalau you deal dengan simple linear regression sebelum ni, di sini will be N minus 2. Right? Sebab dia hanya ada 1X. So dia punya P 2. So sekarang ni kita punya X ada several. So di sini will be N minus P. P adalah depends pada how many parameter that we have. Okay, multiply dengan standard deviation of B1 kalau kita nak cari confidence interval untuk B1. Like I said sebelum ni, kalau gunakan tabel merah dekat sini will be T alpha over 2 sajalah, bukannya 1 minus alpha over 2. Okay, so kalau nak cari confidence interval untuk beta 2, so it will be B2 plus minus T alpha over 2 and minus P juga. Okay, multiply dengan S B2. Okay, remember, daripada variance covariance matrix ni, you akan dapat variance. Tapi untuk dapatkan confidence interval, we will use the standard deviation. So, you kena square rootkan the value tadi daripada table. Square rootkan dulu, baru you gunakan untuk, daripada matrix tadi. Okay, square rootkan dulu the value untuk dapatkan standard deviation for the parameter. Okay. And then, we also, dan macam biasalah, you boleh interpret juga the value of the confidence intervals macam like before. Let's say contohnya, let's say you nak cari 95% confidence interval untuk beta 1. So what can you conclude is, you can say that we are 95% confidence that the value of B1 will lies between the range of the confidence interval. Ataupun you can say that we are 95% confidence that when x1, let's say kalau you nak interpret untuk beta 1, when x1 is increased by 1 unit, you can mention the unit. Okay, the y will be increased between the value of the limit yang you dapat tu, when the other variable, sebutkan the other variable is held constant. Okay. Okay, and then like I said tadi, we can test whether the independent variable is significant or not, whether we want to remain the variable in our model or we want to drop that from the model. So kita kena tengok dulu each independent variable tu significant ataupun tidak. So kita boleh gunakan individual test for beta. Okay, so kat sini beta k equal to 0 or beta k not equal to 0. So it depends pada your beta, you nak test untuk beta 1 ataupun beta 2. Kalau you nak check whether x1 is significant ke tidak, so you check kat sini will be b1 equal to 0, b1 not equal to 0. Kalau you nak check x2 ni significant ke tidak, so here will be beta 2 equal to 0, beta 2 not equal to 0. Dan macam biasa, when we are doing the hypothesis testing, kena ada juga test statistik. So kat sini kita gunakan T test statistik, which is BK divide dengan SBK. BK ni adalah value of your beta lah, parameter, divide dengan standard deviation of the parameter itself from the matrix covariance tadi. Okay, so actually dia punya T ni sebenarnya formula dia adalah beta k minus dengan bk minus dengan beta k divide dengan standard deviation of bk. So beta k here ni adalah actually this value. So kalau kat sini kita test untuk beta k not equal to 0, so di sini will be 0 lah. Sebab itulah kat sini beta bk sahaja. Okay, so kenapa kita check kita punya hypothesis testing is beta k equal to 0? Sebab kita nak check whether our slope, okay, slope beta 1 tadi, b1 tadi is significant or not. Sebab tu kita kena check equal to 0. Sebab kita nak tahu sama ada that slope tadi tu have the relationship with y or not. Sebab tu kena check untuk equal to 0. Let's say kalau you nak check whether your parameter is more than 5 contohnya. So you boleh lah buat kat sini more than 5. So di sini will be 5. Okay, it depends pada you punya intention ataupun hypothesis. Okay, I padam boleh ni. Alright, so dia punya decision rule adalah we reject hash not. Kat sini dia buat conclude hash not. Okay, maksudnya we fail to reject hash not if the absolute value of the test statistic t less than or equal to t1 minus alpha over 2n minus p. Remember kat sini n minus p, not n minus 2. Okay, because we deal with NLR. Okay, ataupun biasanya yang you belajar sebelum ni, kita ingat decision rule untuk reject hash not. Okay, we reject hash not if tukar je lah. Tak ada masalah, sama je. Okay, absolute value of t more than or equal to t, kalau guna table merah, alpha over 2 n minus p. Okay, we reject hash not if t more than or equal to the critical value from table, t table. Okay. Alright. So if we reject hash not, maksudnya kalau reject hash not, kita conclude hash 1. Kalau reject hash not means that dia punya beta tadi not 0. Maksudnya ada value. So means that kalau not 0, kan kalau you punya slope 0 means that tak ada correlation between the variable y dengan x kan. Sebelum ni sama juga dengan ni. Slope untuk b1 maksudnya kita nak check untuk x1 contohnya. Kalau kita check kat sini b1, hash not b1 equal to 0, hash a b1 not equal to 0. So kita check untuk x1 contohnya. Kita nak tahu sama ada x1 ni having the relationship with y or not. Ataupun x1 ni will have the contribution in explaining the y. Okay. So kalau reject hash not, the slope is 0. So means that kalau reject hash not means that the beta, the slope is not 0, means that your value of x1 ataupun the variable x1 is significant. We can say that the variable x1 is significant. Ataupun you can say juga, like I said, macam tadi dah banyak kali saya bagi tahu, we can say that x1 will give the contribution in explaining the y. So you can sebutlah what is your x1, what is your y. Okay. Alright. So let's see the example from your textbook juga sebenarnya. Ini page 245. Okay, from the previous example sebelum ni. Okay, example sebelum ni, y adalah sales, x1 adalah number of person age 16 or younger. X2 adalah personal income. So kita ada 2X. Okay, ada 2X. So parameter ada 3. Beta 0, beta 1 and beta 2. Okay, use all the information that you have from page 237. Okay, we know that X adalah, N ada 21. Okay, ini information from the previous example, page 237, N is 21. Dan juga you have data kat situ. So sebelum ni pun you dah kira untuk X transpose X. You dah create the matrix of X transpose X, which is first of all you need to find all the summation value kan dalam ni. Okay, so let's say we have this X transpose X matrix, then kita inverse kan dia. So this is the matrix of X transpose X inverse. Untuk dapatkan variance-covariance matrix, this matrix tadi multiply dengan MSE. MSE, macam mana dapatkan MSE? It is SSE divide dengan N minus P untuk MLR kan, dari ataupun you boleh ambil daripada ANOVA table. So this is the matrix of X square B that you have. So our intention nya adalah dekat dia punya main diagonal. Okay, dia punya main diagonal ni adalah variance untuk beta 0, variance untuk beta 1 dan juga variance untuk beta 2. Okay, so using all the value of variance tadi dan juga standard deviation, we can find the confidence interval untuk beta 1 dan beta 2. So daripada your example sebelum ni, you dah cari kan beta 1 dan beta 2. Beta 1 that you get adalah 1.455 dan beta 2 adalah 9.366. So sekarang kita nak cari confidence interval. So dekat sini dia gunakan 90% confidence interval contoh kat sini. Okay, so as you know, kita punya formula untuk dapat confidence interval adalah beta k plus minus T alpha over 2 N minus P multiply dengan standard deviation. Okay, so untuk beta 1 it is 1.55 B1 K plus minus T alpha over 2 which is 0.1 divided by 2. Okay, degree of freedomnya adalah N minus P which is 18. Okay, 18 dan multiply dengan di sini adalah standard deviation of B1. Okay, you kena square rootkan value ni dulu baru dapatlah 0.212. Sama juga dengan this one, B2 plus minus T 0.1 divided by 2 degree of freedom 18 multiply dengan standard deviation for beta 2. Okay, then you will have this two confidence interval untuk beta 1 dan beta 2. What can you conclude here? Okay, kat sini we can conclude that with a confidence coefficient of 0.90 ataupun we are 90% confidence that B1 falls between 1.01 and 1.9 which is this interval, and B2 falls between 0.84 and 17.9. Lagi elok, lagi proper if you can conclude about the variable. Okay, which is you can say that untuk beta 1 you can say that we are 90% confidence that when x1 tadi apa, when the number of person age 16 or younger increased by 1 person, okay, the sales will be increased. Kenapa saya sebut increase? Sebab positif, dua-dua positif, will increase between the value of 1.01 and 1.90. Saya sebut dia punya unit sama ada dollar ke, saya sebut. Okay, sama jugalah dengan beta 2. Okay, let's say kalau you nak check pula whether each x tadi, x1 dengan x2 tadi adalah significant ke tidak ataupun should be remain in our model or should be dropped from the model. Okay, kita gunakan t-test. Alright, so let's say kalau kita nak check untuk x1 contohnya, okay, dia punya hash note will be beta 1 equal to 0, hash 1 beta 1 not equal to 0. T statistiknya will be b1 tadi, which is 1.455 minus 0 dengan divide dengan standard deviationnya 0.212. And then you can compare this value, t statistic, comparekan dengan critical value from the t table, which is t, okay, 0 sama macam tadi lah, 0.1 divide 2, 18, berapa? Okay, so if this t statistic more than the critical value from the t table, so we reject hash note. Bila reject hash note, we can say that the variable x1 is significant and it should be remained in our model. Means that this x1 variable x1 is significant ataupun give the contribution in explaining the sales ataupun y. Okay, so sebenarnya gunakan confidence interval juga. We also can use the confidence interval to check whether our variable is significant or not, isn't it? Okay, you still remember? Kita boleh gunakan confidence interval nak check whether our x1 dan x2 is significant or not. Okay. Macam mana? Okay, we can observe whether our interval includes value 0 or not. Betul? If the interval includes 0, kalau include 0 maksudnya ada sebelah sini negatif, sebelah sini positif lah, sebab tu dia include 0 kan. Kalau satu negatif, satu positif, kita memang tak boleh nak interpret kan. So means that the variable is not significant. Okay, satu menaik, satu menurun. Okay, so kalau your interval here does not include 0, then we can say that the variable is significant. Kalau tak include 0, means that both of the interval is positive ataupun both of it is negative. So the interval does not include 0, we can say that the variable is significant. So kalau kat sini kita tengok both of the interval is positive, so it means that no value 0 includes in this interval. So we can conclude that variable x1 dan variable x2 are significant. Okay. Okay, the next one adalah untuk dapatkan confidence interval for the mean response dan juga prediction. Remember? Estimation for the mean response dan juga prediction. So sama je macam sebelum ni. Dalam simple linear regression, the formula is still the same. Cuma sekarang ni kita ada beberapa x sahaja. So you punya matrix of xh ni will be p by 1. Kalau sebelum ni it will be 2 by 1 sebab you akan ada dua parameter sahaja. Sekarang kalau kita deal dengan MLR, parameter you will be p. So this is the matrix of xh, which is the value of x that will be replaced in the data. Okay, so if you can remember this formula untuk dapatkan confidence interval untuk mean response. So this is the mean response. Kita dapatkan dulu mean response. Okay, di sini critical value T alpha over 2n minus P macam sebelum tadi. Cuma kat sini kena multiply dengan standard deviation for the mean response. So you need to find the mean response dan juga standard deviation for the mean response. How to get that? Sama macam sebelum ni. This one. Which is we estimate the mean response with this formula, which is xh transpose multiply b. B adalah matrix of parameter tadi lah. Okay, coefficient tadi. So xhu this matrix P by 1. So X hash transpose will be 1 by P. Kan? Matrix B will be P by 1, right? So you akan dapat satu value lah kat sini, 1 by 1. A value which is dinamakan mean response. Okay, so lagi satu nak dapatkan standard deviation for the mean response. Okay, we have these two formula. Okay, remember, sama dengan SLR. Okay, if you have the variance-covariance matrix, you can use this formula. If not, you can use this formula pun boleh. Okay, untuk estimate the sigma square, we use the S square. So gunakan formula ni lah. S square of the mean response, which is MSE multiply X hash transpose, inverse of matrix X transpose X multiply X hash. Okay, ataupun gunakan this formula if you have variance-covariance matrix. And then, macam sebelum ni, you kena tahu nak interpret the confidence interval for the mean response. Okay, let's see the example. Alright, this example. Okay, tadi Dwayne Studios would like to estimate the expected sales, which is the expected sales maksudnya mean response lah. Y adalah response variable. Okay, in cities with target population, which is your X1 tadi, adalah 65.4,000 dan disposable income, which is X2, is 17.6%. So first of all, you need to create the matrix of XH first, which is dekat sini adalah 1 di sini. Kena ada kan coefficient. Di sini X hash 1, di sini X hash 2. Kalau you ada lagi X lain, kena bawa kat bawah tambah lagi lah. P by 1. Here will be 3 by 1. Okay, so you can estimate the mean response first. Okay, you have this matrix transpose of XH multiply dengan B matrix. Coefficient beta 0, beta 1, beta 2. So you have this value. Right, so another one, you need to estimate the variance of the mean response using this formula. Okay, kat sini dia gunakan this formula because of we have the variance-covariance matrix tadi earlier. Okay, multiply these two matrices, then you akan dapat this matrix. Ni adalah variance. Okay, in order to find the confidence interval for the mean response, you need the standard deviation. So apply the formula. So you will put here. Then you akan dapat this formula. This confidence interval for the mean response. So apa yang boleh you interpret? You can say that with 95% confidence, we estimate that, ada perkataan ni, we estimate that the mean sales, which is the mean of Y, mean of the response. Mean sales in the city with a target population, ni adalah X1. Target population is 65.4 thousand person, age 16 or younger, and per disposable income, which is X2, of $17.6 thousand are somewhere between $185.3 and $196.9 thousand. Okay, put the unit. Alright, so that is the way how you interpret the confidence interval for the mean response. Okay, lastly adalah prediction. Okay, the prediction. This, the new observation. Prediction for the new observation. This is a formula. Sama macam SLR. Cuma bezanya dekat sini je N minus P. Okay, and then you kena cari dulu. Di sini adalah prediction. Formulanya sama dengan mean response. Which is X transpose H multiply B. Okay, put the value here. And then di sini formula untuk dapatkan variance for the prediction of the new observation. Okay, so So kat sini MSE plus S square H, ataupun you can use this formula, either one lah. So cara nak interpret the value, kat sini ada tak? Okay, dia tak ada contoh. Okay, cara nak interpret the value of the confidence interval for prediction of the new observation adalah sama je, cuma bezanya tadi macam tadi, you can say that we are 95% confidence that the mean sales is bla 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 kan. So sekarang you just tukar kepada we are 95% confidence that the prediction of the new observation when x1 berapa, when x2 berapa is somewhere between the interval. Okay, itu saja bezanya.